Hey everyone. Thanks for coming out tonight, especially with the good weather. It's really great to see you all. So, welcome to the third kind of Rust meetup. First, good news: the Rust learning groups are going to return. We will probably join the OpenText School Learners Meetup here in Berlin, and you can find more details to that in the future on our meetup page. It's going to be in September probably. So be sure to check that out. And for today, we are hosted by Blacklane at their awesome office. Thank you very much. And there are drinks, and the toilets are like directly behind this wall. And yeah, you can grab drinks and just come in your life and just hang out afterwards and just chat and network. So we have 2 talks today. One will be by Paige. It's going to be a main talk. She works at MaidSafe, and they do cool stuff with Rust, basically evolving the internet, right? And she's going to talk us through that. And afterwards, we have a small talk by Florian. He's a member of the community sub-team of the Rust language, and he's going to give an overview of what happened there. So for information, the talk's going to be filmed, which means if you don't want to be filmed, don't walk into that area during the talks. Okay, thank you very much. I'll give it to Paige.
Hello. My name is Paige Peterson. I do communications and a little bit of web development for a company called MaidSafe. And I'm going to be talking first, kind of give an overview of the story of our transition into Rust, and then talk about what we're actually building with it, and also how people in the Rust community can get involved with development as well, if that is of interest. So, I gave a kind of a similar talk at the Rust camp, the first Rust camp that was in Berkeley, California, on the 1st. So if you watched that live stream or those videos, then this might be a little repetitive, but it's a cool story anyway. So the Safe Network is an open source, open development project researched and developed by the company MaidSafe. And we're kind of, we've been kind of alluded to by a lot of the Rust community as like being Rust in production, but I want to kind of disclaimer, we're not in production yet. We're still rewriting a lot of or finalizing a lot of the rewrites into Rust. But the launch that we are hoping to have will be imminent. We don't really like to pick dates because things change and sometimes improvements need to happen. So it's going to happen soon. So this company has actually been in existence for almost a decade. The company was founded in 2006 by the founder, David Irvine. And And we've gone through a lot of iterations in terms of what the project was even going to be, and just like coming to sort of a plateau at the end of last year when we realized we had this really huge C++ code base. So the initial research was done in Python, and then we started developing the production stuff into C++. And it was going well. We had a lot of really intelligent C++ developers working with us, so it wasn't a problem with that. But the project, being so the size that it is, started becoming really complex in the code base, and I think at the worst of it, it was 500,000 lines of code. So there was already this kind of thought process in the founder that there needed to be a lot of refactoring and just like taking a step back and re-looking at things. And so eventually he started playing around with Rust. He had been keeping an eye on it for a couple of years, but only in February or March of this year, he actually just took one weekend for himself and decided to port one of the libraries that we had in C++ into Rust and see what would happen. So he was just playing around. He ported this library, and it took him all weekend. He didn't sleep or anything, but he essentially ported one of what he thought was the most difficult libraries in 3 days, and had it run, and it actually just worked. So he was really kind of surprised by this and inspired, and decided to take in a few more developers. So I guess I should say that, so the initial refactoring was kind of happening before Rust, but after rewriting it and then starting Rust, we ended up reducing the code base by 10 times, even after the refactoring. And it has enabled, in general, a very quick iteration and testing process for us. We are kind of in the final stages of rewriting all of the libraries, but we only started rewriting them in April of this year, so we had a few months with the full team working on it, but it's been a very quick process, and just like seeing things work without having to do a lot of testing, and having that all built in, it's been really beneficial for us. So there's a couple of quick quotes that I took from some of the core developers at MaidSafe that I think are funny and inspiring for the Rust community. So this is context of the founder, kind of explaining there was some issues. People were getting a little frustrated having just started Rust and like not being used to the testing process and wanting to alter the testing and whatnot. So he was saying we can't short circuit alter the system of test builds, so we need to work harder to test really. Otherwise we go back to the land of spaghetti and complexity where nobody knows what's happening, and we're not going back there. And that was, I guess, kind of in relevance to the C++ code and how it was really difficult to get the whole thing into your head, and it was becoming difficult for the core developers to work with each other and understand the whole project. And then another quote from a core developer. So his first week in Rust was in March or something, and we started coding when we started coding the Crust library, which is one of our stacks libraries in the network. We had just one test, and I was very sure that we wouldn't be able to get any library to work on the very first attempt. However, I was very happy to be proven wrong. And as I was saying before, with the story with David kind of rewriting one of the libraries and being really inspired by it, so he ended up taking 3 or 4 of our front-end developers didn't want to, necessarily disturb the core development of the C++ while he was experimenting with the Rust things. So he took a handful of developers that were doing front-end things and asked them to implement another library. And it took them a couple of weeks, but they eventually, this is with them just learning the language as well. It took them a couple of weeks, and they were able to do it successfully, and it worked. So that was kind of the final decision of David to just go forward and completely erase all of the C++ code and go all in onto Rust. So yeah, those initially hired for application development are now core developers. Original core developers are also happy with the change. I can't say it's been like rainbows and unicorns, but overall, the existing core developers were excited to work with the new language. We did have a couple of kind of hardcore C++ developers that weren't happy about switching, and we ended up just like, they wanted to keep doing C++, so they went off and kept doing C++, and we got to move forward, continuing Rust and hiring other people that wanted to do Rust. So it was a little bumpy for a little while, but in the end, I think the team we have now is really excited about Rust. And I don't think you're ever going to be able to get rid of people that are, stuck with their old language and are really expert at it, so they don't really want to take on another language. And then another quote from a core developer. This is kind of from an interview that he was doing, and the context is he was talking about how Rust could actually maybe be a good language as a first language or maybe a second language for new developers. So the problem is a very good C++ programmer would be able to write code which doesn't produce any conflicts when it's running on multi-threaded systems, but it requires being awake, and you cannot program in the late hours of the night. It requires a lot of mental effort, and the help of Rust is exactly that. The computer is always there watching over you, and I would venture to say that he didn't mean like the NSA kind of watching over you, but the helpful kind. So yeah, and in addition to kind of empowering a lot of the front-end developers at MaidSafe, our project is interested in getting contributions from the greater community and anyone who wants to. It's an open source project, as I said before, and so because what we're building is kind of this grand scheme to replace the internet with something better, we need kind of people from all different communities, so like networking and security, and we're really aligned with the free software community. So I think there's a lot of alignment with what we're building, and also, just generally building a new language, because we're trying to build this large platform, and then this new language of Rust kind of brings together its own communities. So I think there's a lot of alignment with what the Rust community is doing and what we're trying to build up as well. So I will be talking about the technology so you can understand what's going on if you are interested in helping out, but I just wanted to entice a little bit that we are setting up a code bounty program. So if you want to help maintain the core libraries, then there's potential if your bug fixes or features are included into the code base. You earn based on basically how much time you spent in points, but you earn Bitcoin for the work that you've done. So that's there'll be a link for that at the end, and I'll upload this slideshow and perhaps give it to Johan so he can put it on link it to the Rust meetup, or this event meetup. And we also are building an application ecosystem. So again, we're building this kind of new internet, and this platform needs applications on top. So we've been trying to integrate an ecosystem within the platform itself, so that applications can earn something, can earn revenue a lot easier than open source developers and applications do today. And I'll go kind of more into that when I talk about the technology. And then, yeah, so we've been really thankful to the Rust core developers as kind of one of the first companies, projects going all in on Rust. They've been really supportive and kind of listening to what we need for a stable platform. Right now we're just using the nightly because we're dependent on a few things there, but we've been in conversation with them and they've been really great. So overall, the Rust community has been really great to us, and we really appreciate it. And so much that we've gotten a couple of ideas from the Rust community. Obviously, RFCs have existed for a while, but we saw the RFC use case that for the Rust language development, and so we decided to adopt that for ourselves. Yeah. All right. So now the next one. Yeah. So now I'll just talk about the network and what it is, and how to get involved. But I guess first the technology of it. So MaidSafe, the company, stands for Massive Array of Internet Disks, Secure Access for Everyone. And what it is, the safe network that we're building, is essentially an alternate internet that removes dependence on servers and replaces that with a peer-to-peer network. So instead of servers storing data and doing processes, you have nodes on a peer-to-peer network that are sharing responsibility for processing and storage and bandwidth. And in addition, there's kind of this core ethos that it should be secure and private. So it's not just a decentralized internet, because you could sort of see something like what the BitTorrent protocol is doing as a decentralized internet, but that's not really private or secure. So we've kind of taken that a step further and kind of baked the privacy and security in as much as possible. So yeah, the current internet is centralized and MaidSafe is not. Current internet is, you're dependent on servers, which are these central access points, and if you're uploading files to any of them, then there's potential for them to be lost, whether a server goes down or gets hacked. I mean, there's lots of examples of hacking, I guess, in the news today about why servers might not be the best infrastructure to use. And so the general idea is that if you're kind of decentralizing the network with the security baked in, it's much harder to target things because it's just harder to locate where they are. There isn't like one central place where you can get a lot of information. So that's the general idea behind why there's us and a lot of other projects looking to decentralize networks and infrastructure. So as I said, it's serverless. It's made up of peer-to-peer nodes and clients. It uses client-side self-encryption and self-authentication for the security, and I'll talk about that in a future slide. It works with personal, private, or public data. So essentially, you can, if you were uploading a piece of data to this safe network, it essentially encrypts all of the data into chunks and gives you these encrypted chunks, which come with this key to put all those chunks back together. So you get like an output of chunks and a key. But that key kept for you personally if you're the one, and doing this. If you're doing the encryption client side, then only you have access to that key. Or you can give that key to a friend or maybe a doctor if it's medical related, or a journalist if you want to give them information. Or you can just make it public data and give everyone access to that key. So everything on the network is encrypted because of our focus on security and privacy. But we also want to make it as flexible as possible, so public data has to be easy. And then finally, it's also autonomous, which is key for a decentralized network to sort of grow and scale. It has properties of being able to kind of heal itself and just kind of know what actions need to be taken at any given time. So if a new client wants to upload a piece of data, then there's systems within the network that kind of know that client needs to do something and will make it happen. I'll talk about that whole process as well. So that's just kind of an overview of the goals. And yeah, this is the kind of overview stack of like the whole networking stack. We kind of fit in above the networking layers. And then it's our stack, and then you have an API exposing infrastructure for third-party developers to build on top of. And this is our actual stack. So what you can see again at the bottom, we're working on top of IP, and our network is kind of split into the network, which has these two main layers, the Crust and routing and Sentinel, and then the vaults, which are the nodes that work within the network. And then there's this separate sort of client aspect, which handles all the client-side encryption and whatnot. That's kind of the user interface to the network. So none of this is really user interface, and then the client is what the user interacts with. So Crust is our bottommost layer, and that's what enables nodes to connect to the network. And that is kind of split into two pieces, but essentially what it comes down to is that it takes in all of the networking protocols, as many as you want to implement. We haven't implemented them all, but it's very trivial to implement new networking protocols. But the idea is to kind of have them come in at the bottom layer, and then have a top layer of Crust that sort of just chooses which one that needs to be used, or the one that's available to be used. So it kind of just takes all those protocols and puts it together at the top, and kind of just says, here's a connection, and enables you to connect to really any peer-to-peer network, but we've obviously kind of crafted it to work with the routing protocol that we've built. So that's kind of just the underlying, how do you connect to the network? It's pretty basic, but it's really essential to kind of separating this IP layer with the routing to increase privacy. And so the routing, Sentinel, and vaults are actually kind of the meat of it and how it works. We don't quite have a diagram yet. It seems like it would be really complex to build, and we're still trying to figure out how to visualize it, but I will go over it in words right now. So the routing is based on a modified Kademlia DHT, and it's modified to kind of focus more on privacy and just making upload and routing of data more efficient. So it's just easier to get access to data while also kind of spreading out as much as possible to make it private. And it works with a public key infrastructure, so that's kind of how we base the naming of things, is this public key infrastructure. So vaults, which are the nodes on the network that are routing data. So in addition to storing data, the vaults take on various roles for the routing within the network. So this is where it gets a little complicated to try to explain. But what it comes down to is that there's like this network, language of the network, which is based on the DHT and this XOR protocol. So if you don't know about XOR, it's basically how DHTs have a namespace, and there's an interesting property of XOR such that any two nodes have any node and any other node kind of has its a unique distance. So if you pick one node and you pick any other random node in the network, it will always have a unique distance to that original node. And we can kind of exploit that to create kind of an authority permission system to help drive things that need to happen in the network. So with that said, there's the language and the roles that the nodes are taking on. Yeah.
Sorry, I'm slightly surprised by this thing. If you have a diamond-shaped network or something, I mean, from one node, many nodes can have the same distance. I mean, what's your definition of distance?
XOR distance. So.
You mean in terms of the addresses of the nodes, not in terms of the number of hops?
Right, in terms of the addresses.
That's
yes.
my one. I was just surprised.
Okay. So we use this distance aspect to kind of calculate what roles nodes should take on. And these roles are used to come to consensus about various things that happen on the network, to kind of preserve integrity of data and essentially enable people to trust that the data that they put up there is the data that they're accessing. So yeah, it's based on a consensus of closed groups, small closed groups in the network. So essentially, for example, if a client is trying to upload a piece of data, they're talking to a handful of nodes that are close to them in XOR space, the closest nodes to them in XOR space, and getting a consensus from them to enable that action to happen. And with any action, there's a similar consensus process that needs to happen. It's kind of a new structure, and it is essentially a new consensus mechanism that is extremely efficient. And comparing such a consensus system to, say, like the Bitcoin blockchain consensus system, where you're needing to get a consensus from the entire network, and that causing problems of scalability and speed. By taking these closed groups of nodes and only needing a handful for consensus, there's a lot of potential to improve on the speed of getting decentralized, decentralized consensus. So and I should also say that the roles in the network are, they can change. They're kind of fleeting. So at any one point, any node can be taking on any role within the network based on their distance to a node that needs permission to do something. or a piece of data that needs permission to do something. So essentially all of the nodes have like these set of roles that they can play, and then given a message that they were sent and what kind of node they were sent from, that kind of determines what their role is in the network. I hope that it definitely would improve explaining that with a diagram of sorts, but hopefully that's a little clear. And in addition to this consensus, to kind of avoid, nodes trying to take over or surround a node, or just do anything to disrupt the network, then there's basically a ranking system which kind of watches if they're coming to consensus or not with the other nodes in the network. So if they're repeatedly not coming to consensus with other nodes in the network, they're probably a bad actor, and they probably shouldn't be chosen for any of these consensus things, because there is potential for, in a distributed network such as this, to and there will be a lot of people trying to attack it. So there's a lot of mechanisms that we've thought about to prevent and be able to detect nodes that are potentially bad actors or run by bad actors. So yeah, back to the stack. So that was Crust, routing, and Sentinel. And then the vaults are the nodes that are on top. So they're taking on these roles and storing the chunks of encrypted data. And so the second aspect of the stack is the client, which is the client side. Nothing, all of the information here is sort of kept client side, and again, kind of is working to improve privacy of the users, because none of this data is actually being saved on the network itself to potentially compromise it. So, actually, I'll go back real quick. So yeah, there's all these aspects, but what it comes down to is that all data that gets uploaded to the network is encrypted and goes through the self-encryption process. And that, on top of that, is essentially the API. So any third-party developer will be able to build on top of that and kind of get access to uploading any sort of data for their users, or be able to interact with it. So the self-encryption is quite interesting. It essentially is it essentially enables identity-less secured data. So instead of having something encrypted to an individual, you can sort of use a process of self-encryption, which we developed for being able to encrypt data without having any individual associated with it. So essentially, it uses the hashes of, it's chopped up into chunks, any data. It uses the hash of the chunks on either side to encrypt the chunk itself, and then it outputs all of these encrypted chunks and a single data map. And that data map is what you use to give permission for other people to see it or whatnot. And again, yeah, that's what you would share with someone if you wanted them to be able to have access to your data. And there's also this aspect of self-authentication. So this essentially enables account creation and verification from any computer connected to the internet without any third-party authority. And what it does is it generates a unique access ID, and and to be stored on the network. And that's essentially your passport, which has all of your data map keys in it. And that's kind of how, that's kind of setting up the account at first, and then when you want to re-log into the network, essentially some nodes that are responsible for being your client managers will send you essentially a token, an encrypted piece of data that you have to decrypt locally, and then and re-encrypt it and send that back to the network. And that's kind of how we are able to authenticate a user without needing a permission from anyone else, or giving them our permission at all. So the network is able to recognize that a user is logging back in based on these kind of consensus roles within the network. And there is potential for perhaps someone to try to brute force that, or try to attack that login system, but it would be really computationally expensive, because you would need to be providing the login credentials each time you're trying to log in. But even when your login credentials aren't valid, the network will send you a packet to decrypt anyway. So there's essentially just an infinite amount of tries that the network could give you, and you wouldn't even know if you're using the original correct ID or not. So it makes it just extremely computationally expensive. And so this also benefits the developers that are using the platform itself, because you're essentially just getting authenticated and getting access to the network as a whole. And once you do have access, and once you have access to your data, then the third-party applications using it can just interact with you on the client side, and they don't need to know any of your data. And it's great for users. It's also great for developers, because then they're not liable for storing users' data or their keys. And so I mentioned the kind of developer application rewards. That's kind of integrated with the ecosystem that we're trying to develop within it. So what a huge problem with a decentralized network like this is the fact that humans are using it, and humans are self-interested, and for the most part, and there's going to be people that are not providing any resources to the network, but uploading as much data as they want to the network. So the goal is to kind of balance that out and try to create an ecosystem that's fair. So what it comes down to is we've created this proof of resource concept, which essentially rewards people that are providing resources. So resources to the network is storage, computation, and actual connectivity to the network. You need to be connected to the internet to be able to be useful as a node. So taking all that into consideration, and you are essentially entered in a lottery of sorts to earn a token every time a user is able to successfully get an encrypted chunk from your node, your vault. So by accumulating these tokens, you then have more benefits to store new data to the network. So anything on the network is free to read and to get all the data that you want, as long as it's accessible to you. However, putting new data to the network will require this token to save, because again, individuals, there's a high chance for some individuals to just upload all of their data and never provide any resources themselves. And we're definitely interested in ways to help this kind of like equality work better. It's still going to be a tough problem to solve, especially with, you know, getting these tokens in the hands of people that can't necessarily afford, you know, afford space on their computer or whatnot. So it's definitely going to be like a long-term solution, and the project as a whole is a very sort of long-term solution to what we think is wrong with the internet. And yeah, I guess you can sort of imagine what it would be like if there was some way when the internet first started to have, you know, micropayments for content or developers. There's a lot of potential in empowering these sorts of people, like open source developers and journalists and whatnot, that don't necessarily make a lot of money or need to depend on sponsors, or, you know, just removing dependence on sort of middlemen in general for the content that you create and the services that you create would really benefit from having sort of an internet-based token system or currency that could kind of facilitate that process, because the current economy doesn't really necessarily work with the digital world. Might be obvious or not. Yeah, so balanced consumption, availability of space. And then, so SafeCoin is the asset, the token. And again, it's acquired by providing resources to the network and required for putting new data to the network. And SafeCoin is an interesting asset by itself, because it's kind of the first attempt at building a cryptocurrency that's not a blockchain, and based on the consensus that we've built. So because it's not this global ledger, there's a lot of potential for this token to be anonymous and essentially not put on a huge list for everyone to see. Essentially what happens with a SafeCoin transaction is once you get permission from your, again, these roles are coming into play, you have essentially transaction managers for sending a coin or any asset to another node in the network, another client in the network. You're basically getting consensus from a group of nodes, and yeah, and once those nodes come to consensus, your ID is kind of shifted down one on the coin itself. So the coin stores the current owner and the previous owner. So once you send it, you are the previous owner, and then there's a new current owner, and that shifts. And once someone resends it again, you're kind of wiped off. So that's where the privacy and general ability to stay anonymous happens with that, with tokens and any data on the network. So this is, I don't know how fast I talked. I think I was trying to talk slower, but maybe that didn't work out. But this is a bunch of links that could be really helpful. So we are open source, open development. We have everything, all of our libraries are GPL3. You can see all of our code on MaidSafe, the GitHub MaidSafe. We also have our open development is kind of organized around our Atlassian site, which is a public site, and you can essentially see exactly what we're doing, which person is doing what task, and how quickly we're moving through it. And yeah, that system has helped us out a lot. And obviously our crates are on crates.io, so if you just search MaidSafe and crates.io, then you can see the libraries that we put up there. We have a community forum, which is very active with all different sorts of people. We'll probably end up making a separate developer mailing list. We have one currently, but it's Google, and a lot of people don't like Google, so we're going to switch to another mailing list. But we'll announce that in all sorts of places. And then the documents page on MaidSafe.net has a lot of papers that have been written about from the founder and based on various parts of the network. So there's like a self-authentication paper, self-encryption paper. You can read through those if you're interested. And then some sort of more low-level technical overviews of what I was giving a high-level overview of can be viewed through those links. And if you want to contact me, my contact info is up there. And again, I'll make this slideshow public in some way, probably on the Meetup on that page. But I guess that's it, and I can take questions if you want.
Thanks for the talk. Really interesting. How many developers work on this? Looks like a really ambitious project.
Yeah, so it's grown over time. There's David, the founder, and a couple of people he trusted started off the company, and there were not many of them in the beginning, but now we have about 25 individuals. 15 or so are, maybe a little more, 15 or so are in our headquarters, which is in Troon, Scotland, and the rest of us are kind of distributed throughout working remotely. That does remind me that I forgot to add to the slideshow that we're hiring. So we're really interested in hiring Rust developers. So specifically, like we probably hire anyone that's like really interested in this and like wants to can kind of showcase ability to program in Rust or ability to pick it up quickly. However, we're specifically looking for a networking engineer and a system architecture. So kind of a couple of intense roles, but if you're still like interested, there's again that bounty program that I think could help a lot of people who are just kind of experimenting with Rust and want to play around with Rust that don't necessarily want to build a whole project yet or whatnot.
At the beginning, you said that one of your libraries was written in Rust.
All of
and
them
it was,
have been, yeah. Yeah, go ahead, sorry.
Let's say one of them
Yeah.
was written in Rust, and other ones was using C++. How they communicate?
Sorry,
Right.
I guess I didn't make that clear. All of our libraries are in Rust now. That was kind of just the story of us transitioning into Rust. So at first it was just one library that the founder rewrote, and that was successful and it worked. So he decided to pull other developers aside and rewrite all of the other libraries. So we don't have any C++ code anymore.
So how was the transition between from C++ to Rust? Did you just stop using C++ and rewritten everything in Rust?
I mean, we were using kind of the C++ code as reference for certain, functions that happened in the network, but Rust kind of enabled us to refactor a lot of things in general, so I don't think much of the original C++ code would even work like interoperably with the current Rust code. So we've definitely, like, just doing Rust has kind of triggered this continuing like refactoring and realizing that we can make this simpler kind of thing, and so it's come a long way.
Just to make sure that I did get this right, so you said that at the peak you had something like 500,000 lines of C++ code,
Yeah.
and after refactoring you're down by a factor of 10, so you're now doing all of this within 50k lines of code?
Yes, even less. It's around 10,000 at this point. So it was the initial refactoring kind of got it down to let's see, about 100,000 lines, and then we were able to reduce it even more.
That's very impressive.
Yeah, I think it's really, I'm very impressed too. I can't say like, I'm not really a core developer, so I can't really like relate what the code looked like before and after, but just like hearing stories from the core developers, it's a lot simpler, and they're able to understand what they're doing and what other developers are doing a lot easier now.
How does the company earn money?
Yeah, so we're also an interesting company in that regard. So the original funding of like the few people that were doing research in the beginning, like in 2006 through 2010, they were funded by family and friends, just being interested in what they were building. And then as the company grew, definitely needed more money. So last year, we essentially did this crowd fund type deal where we decided that, this kind of ties into the safe coin thing. So there's only going to be a certain number of safe coins. I don't remember that exact number right now, but it's going to be a hard, fast rule in the network. And we decided that 10% of those coins could be kind of pre-sold to a group of people that would be willing to support us. So we essentially made this proxy token because this network doesn't exist yet. So we created a proxy blockchain token that people were able to give us Bitcoin for, and we would be able to give them this token. And so now people have these proxy tokens, and they kind of trade them around like all other cryptocurrencies right now. But we were able to raise, at the time it was like $8 million US in Bitcoin cryptocurrency.
Sounds a bit like a stock market.
It's the market, right? It's like it's definitely an interesting line, so to say, with like regulation and whatnot. But we call them a token. They're definitely not equity. Like they're access tokens. You're going to be using them when you're able to get access to the network. So there is potential for the price to go up, but it's not equity. Okay. I'll be around, so feel free to ask me questions.
So we'll just continue. I think Florian.
Smoking break?
So I think Florian won't have that much to say. So if you don't mind, we'll just continue with the sub-team report of Florian, and then afterwards you're welcome to take a smoking break or have a beer. I think there's lots of beer available. So yeah, we'll just continue with Florian.
So I basically only got a little announcement and a few things to say about the current state of the Rust language ecosystem. Since the last meeting that we had, there has been a change in the whole governance structure. Especially there has been a new sub-team, which is the global community sub-team, consisting of 8 people from all around the world. Most people that are from the Ruby community will probably know Steve Glabnik being on that as well, and I'm on the team as well. So I'll probably in the future give some reports on what we did and what's happening in this group. One of the things that the Rust community team acts as 2 things. First of all, we're supporting Meetup organizers, conference organizers, and everyone in getting the Meetup set up, working on the conference, support for organizing and giving out all our experiences in that. Most of the people in that team have multiple years of experience in actually running events, and also trying to be sort of a contact point to the rest of the team. If you don't know who to write to with a certain issue, you might have an issue that you might not want to write directly to the core compiler team or someone else, you can just write to the community team, and they will act as a switchboard. And one of the things that have been set up in the recent month, which you can see the results of currently at internals.rustlang.org, which is the compiler internals forum, it isn't the internal forum, is that we made a couple of interviews with current production users of Rust. It's a pretty broad way of stating what production is, so we also had companies that don't quite have Rust code in production but are actually seriously using it. And so we had a couple of interviews, took out what was interesting from them. And for example, on last Friday there was a blog post published with the current roadmap of Rust towards the end of the year. One of the most interesting things probably being that Rust is aiming to be an ecosystem where cross-compilation is just a switch, where you can basically say, okay, I want my code being compiled for an ARM processor or for a Linux system and something like that. And you will, the whole library ecosystem will automatically download the files necessary for that to cross-compile without you having to do anything like that. That's one of the goals for the next half a year. The other thing that the Rust community team does is doing outreach towards other projects and trying to find ways where we can grow into. Currently, we're very interested in game programmers interested in Rust, because that's, for example, a topic where we don't quite have a lot of visibility on what the needs are and what the issues with the language are currently. And as we're iterating pretty quickly, those can even be fixed in the next half a year. But if we don't know anything, we can't fix it. Another project that we did this month, basically, was, two actually. There was the first Rust conference, the 1st and 2nd of August in Canada somewhere. I think it was in Berkeley, California, sorry. And it was a full conference for one day on Rust topics. You can see the videos online. Paige was there, so you can see the recording of her talk and all the others. And also sending speakers to a couple of conferences. There were interesting talks at the Curry On conference. Sorry for the pun. What we also did was, together with Ruby Berlin and Node School, had a village on CCC Camp, which has been a huge success. For 2 days we thought we ordered too many chairs and too many tables, and in the end we managed to fill it all. That was a crowd-funded effort. So we also tried to make sure that events can get funding somewhere, because tents in CCC Camp obviously costs a little bit for having the tent set up and everything like that. And there's going to be future action for that. One of the current future actions for Europe, if someone is interested, we'd like to set up a dev room at FOSDEM. If you know the concept of FOSDEM basically gets the university in Brussels, and as long as you can provide a program for one day, you get one of the rooms, you get video equipment, and you can do the talks and recording and everything, and that's for free. You just have to do the organization. If someone of you has interest in actually going into that space of actually doing these kinds of community works, providing spaces and finding speakers, we can support you in that. We're currently searching for someone who wants to run this. It's, I would say, from the difficulty level, pretty low. You basically get all set up. The only thing you need to find are people, and you need to be there. This at the beginning of February. And people that want to do the same around other events. Finally, there is now a German bulletin board, which also has a pun in the name. It's called Rastplatz, Rastplatz.de, with a U. And we want to have more people there. I think it's a very good thing to offer resources in localized languages and to be able to discuss in your native tone. So we've got a German one now. Hopefully there will be more coming in that regard. Yeah. That's basically it. Are there any questions on that?
not on that, but regarding the language, about numerical exceptions. Is there anything in the planning for Rust?
I can play switchboard immediately. Give me your email and I will forward you to someone from the quality. Yeah, I'm not part in any of the technical teams. So I'm sometimes, the problem is if you're doing too much community work, you're lagging behind on the technical parts. So, okay. Well, thank you.
Thanks for coming. That's it for tonight. You can definitely hang around, as I said, like 3 times already. There's lots of beer for free, so take a chance.